All right, everybody, so here's the 2.6, 2.7 review. It first says, write the quadratics in standard form. Standard form, we just need to FOIL it out. So x times x, that's going to give us x squared. X times negative 6 gives us negative 6x. 1 times x gives us positive x. 1 times negative 6 gives us negative 6. The 4 still needs to multiply in. So we have this is equal to 4 times x squared minus 5x minus 6. Now we multiply the 4 in, so you get y is equal to 4x squared minus 20x minus 24. And that would be standard form. For the next one, again, we're going to FOIL, but we first need to expand x plus 3 squared into x plus 3 times x plus 3 minus 4 on the end. So that's going to give us 5x squared plus 6x plus 9 if we do the 3x plus 3x minus 4. So that's going to be 5x squared plus 30x plus 45 minus 4. So then the standard form here is going to be y is equal to 5x squared plus 30x plus 41. Okay, and that's because 45 minus 4. Next it says write the quadratic in vertex form. What is the vertex? So we need to complete the square. A is already 1, so we take b, we cut it in half. That gives us negative 4. We take negative 4, we square it. That gives us 16. So y is equal to x squared minus 8x plus 16 minus 16 plus 22. And then now we have perfect square trinomial. So y is equal to x minus 4 squared, negative 16 plus 22. Oh gosh, what is that? 4 and 2 is 6. So that's going to be positive 6. And that's all you'd have to do. Now we need to complete the square when a is a number instead of just 1, right? So here we're going to take the negative 2 out of the first two terms. So now we have negative 2, x squared minus 8x plus blank minus blank. The negative 21 stays outside the parentheses. So then we go negative 8, cut it in half is negative 4. Negative 4 squared is 16, so we're filling in 16s. So now we have negative 2. That's going to be x minus 4 squared, and then that minus 16 gets dropped down as well, minus 21. Negative 2 times negative 16, because we need to distribute the negative 2 in. So you get negative 2 x minus 4 squared plus 32 minus 21. 3 times 2 is 1, 2 times 1 minus 1 is 1. So then this final answer would be y is equal to negative 2, x minus 4 squared, and then that's going to be plus 11. All right, vertex for these two things, we have 4 and 6. And then for this one, we have 4 and 11. All right. Next, we have writing the quadratic in intercept form. What are the intercepts? So we're going to come down here. This is a factoring question, so we need a factor. We're going to go x and x. Negative tells us plus and minus, and it looks like minus 5 plus 3 would give us negative 2 in the middle. So that's our equation right here. The intercepts would then be intercepts are points, so negative 3 comma 0 and 5 comma 0 would be the two intercepts. Let's see, it's a different color. For the next one, it looks like 3 and x come out of both. So we pull out 3x, that leaves us with x minus 5, and that's as factored as we can get it. So 3x and x minus 5 would give us intercepts of 0 comma 0 and 5 comma 0. You have to set each of those things equal to 0. So 3x equals to 0, x minus 5 equals to 0. So that's how we get the 0, and that's how we get the 5. All right, next it says use the function f of x and the graph of the function g of x to answer the following questions. State the minimum or maximum of each function. So let's do light blue here, and we will do pink for our g of x questions. So our maximum for f of x, so the max of f of x. We're talking about the vertex here. Okay, so the maximum value, or the vertex, is going to be at 2, negative 1. So f of x has a minimum of negative 1, while our other function, g of x has a vertex at 1, 2, 3, 4, negative 2. So that's 4, negative 2. So it also has a minimum of, and that's going to be negative 2. They're both minimums because a value is positive here, and then because we're opening up, that's also a positive a value. Identify which would be lower on the graph, and then the other, justify your choice. Okay, well, g of x is going to be lower, and then my justification is literally that negative 2 is smaller than negative 1, right? Or negative 2 is more negative than negative 1. Which function grows at a faster rate? Provide evidence to support your answer. So we're talking about growth or rate of growth. This is specifically asking us about the a value. So what is the a value? Well, for f of x, a is equal to 4. Okay, that's seen in the equation. A is 4. G of x, we have multiple ways of figuring out what the a value is. If we're really good at graphing, you can see as you go to the right one, it goes up 2. So that would be an a value of 2. Okay, if we're not good at graphing, let's write an equation for g of x. So we have this point, which is positive 4, negative 2. We also have intercepts here and here, which is 3, 0, 4, 5, 0. Okay, so now we can write an equation in vertex form. So let's go with 3, 0. So 0 equals a, 3 minus h, which would be 4 squared, plus k, which would be negative 2. So that's 0 is equal to a times negative 1 squared minus 2. So we add 2. You get 2 is equal to a times 1. So a is 2. All right, so which is growing at a faster rate? We can see that an a value of 4 will go up faster than an a value of 2. Okay? And that is because when you multiply y values by 4 versus when you multiply y values by 2, the multiply by 4 is going to be larger. C says identify the zeros of g of x. We just did that, right? So the zeros would be x equals 3 and x equals 5. For E, it says identify the x-intercepts of f of x. It says hint, set equal to 0 and solve for x. So we set 0 equal to 4. X minus 2 squared minus 1. So we add 1 to the other side. You get 1 is equal to 4. X minus 2 squared. Divide each side by 4. That gives us 1/4 is equal to x minus 2 squared. Square root both sides. As soon as you take the square root, where we go on plus or minus, square root of 1 is 1. Square root of 4 is 2. So that's equal to x minus 2. And then we add 2. So you get 2 plus or minus 1/2 is equal to x, which tells us that the x-intercepts would be 2 plus 1/2 is 2.5. So you can go 2.5, or you can say 5/2. So 5/2, 0. And 2 minus 1/2 would be 1.5, which would be 3/2, 0. You could also say 2.5, comma 0, and 1.5, comma 0. Both are great answers. It says graph f of x labeling key points. Well, this is fantastic that we already have the x-intercepts. So 2.5 would be right here. 1.5 would be right here. We know the vertex is positive 2 and negative 1. So that's going to be right here. And then we need one more point. So why not find where we cross the y-axis actually. So let's go y-axis, or we can just count, right? We go to the left 2. So normally that would be up 4, but multiply by 4, that's going to be 16. So we're actually off the graph here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16's up there. Okay, we're good with 3 points. Let's just graph it. Oh, wait, what am I saying? If we go to the right 1, we can just go up 4. 1, 2, 3, 4. To the right 1, up 4. Okay, there's our 5 points. Beautiful. So we can fit 5. We can fit 5. All right, and what that was, literally just plug in 1. If you don't understand that, y equals 4 times 1 minus 2 squared minus 1. So that gives us 4 times negative 1 squared minus 1. So that would give us 4 minus 1, which then becomes positive 3, right? So then we plot that, 1, 2, 3, boom, and boom. G says write the equation for g of x, which that's lit. We already did that earlier in this problem. So we found the a value to be 2. So it's intercept form, so we're going to go y is equal to 2, x, and then minus 3, x minus 5, and we're done. All right, so that would be all of number 7. Moving on to number 8, it says write the equation of the quadratic given the following information. So it says the x-intercepts are negative 1 and 2, and it passes through 1, 4. Okay, so let's plug in everything we know, right? We know that negative 4 is a y value. We know that the factors are x plus 1 and x minus 2. So we can go 1 plus 1 and 1 minus 2. Negative 4 is equal to 2 times negative 1. Oops, I forgot my a value. We don't know the a value, so we need to put it in there. So this is going to be a times 2 times negative 1, a. Divided by negative 2 on both sides, we get a is equal to positive 2. Now we can write this equation. Y is equal to 2, x plus 1, x minus 2. Boom. Next, we're taking a look at vertex form, passes through 3, 3. So again, plug in everything we know. We know 3 is equal to a, x plus 1 squared plus 5. We know that that x is actually a 3. So I'm going to subtract 5. Gives us negative 2 is equal to a. 3 plus 1 is 4 squared. So divide by 16. So that's negative 1/8 is equal to a. So we get y is equal to negative 1/8 x plus 1 squared plus 5. The quadratic has x-intercepts at x equals 2, x equals 5. So intercept form is probably the easiest here. That's x minus 2, x plus 5. And a y-intercept of negative 5. So that's 0, negative 5. All right, and then again, let's plug in everything we know. We know negative 5 is y. We don't know a. We know 0 minus 2 is going to go in there, and then 0 plus 5 is here. So that's negative 2 times 5 is negative 10. So negative 5 is equal to a times negative 10. Divide by negative 10 on each side. And you would get 1/2 is equal to a. Whoops, that's not our answer. Y is equal to 1/2 x minus 2, x plus 5. That would be our answer. Next one says the quadratic has a vertex of negative 3, negative 5, and a y-intercept of 13. So y-intercept is 0, 13. So plug in everything we know again. Change colors again. We got 13 is equal to a. We know 0 is x plus 3 squared minus 5. So we add 5 to both sides. You get 18 is equal to a. 3 squared is going to be 9. So divide by 9. We get a is equal to 2. So y is equal to 2, x plus 3 squared minus 5. All right. The quadratic has a vertex of 0, 0 and a point at 2, 8. And it opens upwards. So vertex at 0, 0. All right. So let's actually just write that in to vertex form. So that's going to be y is equal to a x plus 0 squared plus 0. So then we're going to go y is equal to a x squared. So then let's plug in the 0.28. So we're going to go 8 is equal to a times 2 squared. So it's divided by 4 on both sides. A is equal to 2. So we get y is equal to 2x squared. Boom. And then the quadratic has the following points. So 0, -3, 1, -7, -1, -7. In class, I told you the nicest way to do this one. I didn't actually give the a value in this case, but we can figure out the a value, right? So this is going to be 0 to 1. So as we go to the right 1, how does this change? We go from -3 to -7, so that's up or down 4, right? So that's -4. So that tells us the a value is -4. So then we can go here. This is the y-intercept, or the c value. So then we are going to say y is equal to -4x squared plus bx minus 3. Plug in what we know. We know that -7 is y when you plug in 1, so -4 times 1 squared plus b times 1 minus 3. So I'm going to add the 3 over. Actually, we'll wait to do that. -7 is equal to -4 plus b minus 3. So that's going to be -7. So -7 is equal to -7 plus b. So if we add 7 to both sides, we get b is equal to 0. All right, so then our equation is y is equal to -4x squared minus 3. All righty. So this question is, a town is holding its annual music festival 6 months from now. Based on your last year's ticket sales and survey results of how many tickets could be sold, a study group presents the data shown. The variable C presents the cost of the ticket, and P presents the estimated overall profit. So this is a quadratic regression question. I'm actually going to come back to it, and I'll throw a little video on the end of just going through that one. So question 15, I said this was going to show back up again. It says the Park Association has just bought 200 square foot piece of land to build a statue honoring mathematics. The statue is going to be 2 feet long by 3 feet wide. So we have this 2 foot long thing. I'll go too long here. 3 foot wide here. So it's this shape. They want to put a flower bed around the statue with uniform width. How wide should the flower bed be to use up all the space at the park associated? Uniform width flower bed, so we're going X on each side. All right, so it's going to look something like this. And then we can build that border. So our equation, we got 2 x's, right? So we're going to go 2x plus 3 times 2x plus 2, because the 2 x's on each end, plus the distance of the width and the length. This gives us a total area. So this would give us all of this area in here. What is the total area of this question? The Park Association just bought 210 square foot piece of land to build a statue. 210 square feet is the entire area. So we're going to go 210. All right. So then from here, we should just be able to solve. So we're going to go 4x squared plus 6x plus 4x plus 6 is equal to 210. So that's 4x squared plus 10x plus 6 is equal to 210. So 210 minus 6 is going to give us 204. So that's 4x squared plus 10x minus 204 is equal to 0. All right. Does 2 come out of everything? Do I want to do this by hand? That's the real question. Let's not. Let's throw this into our calculator. 4x squared plus 10x minus 204. Zoom 6. Crosses perfectly at some spot. Let's see. We get x equals 0, so it's going to be x minus 6, because x is equal to 6. So then we'll find the other one with that. So that's 204 divided by 6. So that's 4x plus 34 equals 0. So then let's go x equals 6. So how big is the width of the flower bed? 6 feet. All right. So that's all of that. See it? It says use the quadratic regression feature on your calculator to approximate the quadratic function model for the graph. What is the equation? So we need to go stat, we need to go edit, and then we need to clear our lists. So clear list 2, clear list 1. Okay, fill this in. Cost in dollars is C. P represents the overall profit. So let's put the cost as our x's and our profit as our y's. So cost is going to be 25, 30, 35, 40, 45, 50, 55, and 60. Then our y's are going to be 2, 17, 28, 30, 34, 26, 21, and 7. All right, my lists match up. Now I'm going to go stat, calculate. We need a quadratic regression here. We want to store regular equation as our y1. So we go vars, y1. All right, and then I'm going to click calculate here. So our equation, our regression equation is y is equal to negative 0.091, so we'll go 3 decimal spots, plus 7.837x minus 136.685. All right. So it says, what do the x-intercepts of the models represent? So let's take a look at this graph, see what we graphed. So if we're messing with our window, it says it's going from 25 to 60 with our x's. It looks like P at 2 and 7. So our biggest x value that we need is a little bit bigger than 60, so I'll go 65, or sorry, nope, we need 20. We're going minimum value, so 20. Biggest x value is going to be 65. We'll count by 5s here. Y minimum, we need to see into the negatives, so we'll go negative 10 is fine. Y maximum, it looks like 34 is the biggest on the table. My guess is it goes a little bit bigger than that. We're going to go 40. We'll also count by 5s here. Okay, graph. All right, sweet. So let's talk about the x-intercepts. X-intercepts are going to occur here and here. And what they would be is the x value is cost of ticket. The y value here is profit. So the y is 0. The x is some number less than 2. So what do the x-intercepts represent? They represent where you would have, or let's not say where, the cost of the ticket. So the cost of the ticket where you make $0. Or no profit. You could say no profit. What ticket price does the model predict that the town should choose to maximize profit? Well, maximize tells us maximum, so we're going to go second trace, maximum. We need to make sure we're to the left because it's asking for a left bound. Then we need to make sure we're to the right because it's asking for a right bound. And then we click enter, enter. And maximum. So it looks like the to maximize profit, we want our tickets to cost $43.19, so 20 cents. $43.20. What is the profit to the nearest $1,000? So it says that would be 32.575 thousand. So we're going to go, that would be 32.5, or not 0.5, so $32,575, and it asks to the nearest dollar, and 1 does not round up that 5, so we're at 32,575. All right, and that's how you would do number 14 on the review. All right, you will have graphing calculators for this quiz on this week, so as always, guys, if you have any questions on anything that I did on this review sheet, just message me on Canvas. I would love to answer them for you. Alrighty, good luck studying.